Greetings, viewers and judges. Today, I myself, Raja, and with me today we have Farel, Zafi, and Kesa. We are participants of the Sampoerna Academy STEAM competition engineering aspect. And with that, we'd like to present to you our product, AQUASH. Please take it away.
So the problem it shows is that swimming in untreated pool water can result in parasitic algae and fungal infections, all of which pose serious health risks and unpleasant symptoms. Blue-green algae can produce toxins causing skin irritation, respiratory problems, and gastrointestinal issues. Not only that, leaves, especially when they build up over time, can quickly transform your pool water from sparkling and clear to murky and unappealing.
All right, now for the exploration. After the problem identification stage, we decided on three main ideas. The first one being a remote-controlled submersible cleaning device, submarine, a remote-controlled cleaning rover, and a whirlpool machine that attracts floating leaves on the floor. The problem with some of them were first, the rover had wheels and treads, which would be difficult for it to gain traction, and also the rover would not be able to clean the floor of the pool. Now, the whirlpool device has too much electricity, which makes it dangerous and requires so much energy, as well as being ineffective to test. That leaves the submarine concept as the most plausible solution, which we use Bluetooth technology to command, and we use the formula density equals mass over displaced volume to control its density.
So next is the design. So in this sketch, we decide to place the net on top of the submarine so that it can catch all of the floating leaves on top of the pool, while the raw sponge is located beneath the submarine so that it can clean up the wall mosses while it dives underneath the pool. To allow the submarine to float up and down, the syringe acts as a ballast tank. There are two propellers, one for forward thrust and one for side-to-side turning, and both propellers connected from the motors to the outside via magnets. And both of the syringe of the propellers are attached to the gears that are connected to the motors, and all the motors are connected to the motherboard, which receives input from the Bluetooth controller.
Okay, so here's the creation of the physical prototype. As you can see, there is a forward drive shaft propeller and one mounted at a 90-degree angle for side to side. And there's a net on top, as mentioned, as well as a scrubber. Now, in the internals, there is a motherboard, CyberPi CPU, the encoder motor for the syringe, and as well as the two drive motors.
When the prototype was tested, unfortunately, the submarine was not dense enough to be able to sink, and it was also at an imbalance, which caused it to tilt forward, as seen in the picture beside. Not only that, but the magnets also were stuck onto the propellers using magnets, and these magnets were stuck on using glue. And because they were exposed to water, the glue ended up breaking apart, and some magnets were lost inside the pool, never to be found again. Thankfully, our saving grace were the syringes were able to act as a ballast tank successfully, which only worked with very little inconvenience. That is, that it takes the water in very slowly. But we see this as almost a saving grace as well, because this allows us to control the buoyancy of the submarine with extra precision as well. This is a video footage of a successful testing of the ballast tank, discharging water very carefully and very slowly. And beside that, we also have video footage of us controlling all the motors using a Bluetooth controller. You see the propeller controllers and the main controller in the middle that controls the ballast tanks all being moved by the controller.
So after the less than successful test, we went back to the drawing board to calculate exactly how much extra weight was needed to make the device neutrally buoyant in comparison to the surrounding water. After further discussion, we decided that the modifications that we should make are to replace the plastic container with a glass one and fill the inside of the container with the right amount of heavy metallic sand.
Lastly, we have communication. Clean water and sanitation is one of the sustainable development goals. Therefore, our group decided that we wanted to solve the problem with our submarine and show that it can be solved feasibly and accessibly. When walking around the pools, we also realized that leaves often fall into the pool, making it dirty. And therefore, the submarine is equipped with a net designed on top to be able to pick up those leaves. And it's also able to dive down and clean the bottom of the floor and the rest of the walls with the sponge attached to the bottom of the submarine.
With that, these are the resources that we've used during our experiment and research process. And thank you everyone for listening to our presentation.